And linearity. Linearity means two things. If a system or a circuit is linear, it has two properties. One property is the superposition, and the other property is homogeneity. Consider a system its name is H, for example. That system has an input and it has an output. Okay, you give some input values. For example, electrical systems accepts voltage, current, or power as an as a signal. You give some signal, and it operates on that signal. It gives you another signal. Okay, and the output signal can be signals in electric systems. They can be voltage, current, or power. Okay, so X is the input signal, Y is the output signal. Consider the same system. I will partition the input X. Okay, I define two different signals, X1 and X2. The summation of X1 and X2 is equal to X. And I define a signal. I define two signals, Y1 and Y2. The summation of Y1 and Y2 is equal to Y. Okay? Or let me not define this first. First, I have defined X1 and X2 summation is X. Remember, X is the input of the system and Y is the output of the system. I will use the same system. Okay, the same system. But now I apply the input X1. Okay, some partition of X. And I use the same system or the equivalent system. Okay, I get two of that system. I apply X2. The output of input X1, okay, when I apply X1, I get some output, Y1. When I apply X2, I get another output. And remember, when I apply X, I get Y. If that system is linear, if it contains linear components, I can say, I know this. Okay? If system is linear, Y should be equal to Y1 plus Y2. Okay? If the system is linear. For example, let me give some example. If X is 5 volts, when I apply 5 volt, okay, I get Y is 10 watts, if that system is linear, okay, x1, for example, I apply 2 volts, I should get 4 watts. If I apply 3 volts, I should get 6 watts. So because that system is linear, when I apply x1 plus x2, okay, to the system, output should be equal to y1 plus y2. Okay. That's called this is called the superposition property. Okay. This is called superposition. This property. Superposition. Okay. In words, I can say the superposition says summation of individual responses of two different inputs is equal to the response of the summation of inputs. Okay, these are individual inputs, x1 and x2, individual. Okay, I apply them individually, I get individual outputs. I get 2 outputs. If I add these 2 inputs, summation is x, and if I apply x as an input, 1 input, the output of x should be equal to the responses of x1 and x2, which are y1 and y2. So y should be equal to y1 plus y2 if the system is linear. Okay. Yes. If the system is composed of linear components, it's linear. That's it. Okay. If you draw a graphic, what does linearity mean? If you draw a graphic, if you have a component, for example, a resistor, it has a current, it has a voltage. If you draw the component characteristic graphic, you will draw something like that. So it's a line. Okay, it means resistor is a linear component. Yes. Or for example, if you have a source, independent source, if it's a voltage source, this is voltage, this is current, you will see a line like this. Again, it's a line. Current changes, but voltage is fixed. Voltage is always the same. Okay. For example, if this value is Vs, this is Vs. Current changes. If you draw the characteristic behavior of a current source, you will see something like that. Okay. This is current, this is voltage. The voltage of the current source changes, but its current is always fixed, constant. Or if you have a dependent source, okay, it can be a dependent voltage source or dependent current source. They have the same property. Then you will see something like that. Okay, because, for example, it can be a constant C times, C is a constant, C times some variable, for example, C times Ix. Ix is the current of another component. Or this is, for example, D times Vx. Okay, Vx is a voltage of another component in the same circuit. Yes, they are linear too, but they don't have a fixed voltage, a constant voltage, or a constant current. Okay, their voltage and current is linearly proportional with another voltage or current in the same circuits. Okay, their voltage and current is not constant, but it's linear. Okay. For example, how can a dependent source be a non-linear? If you have a source like that, look, A times Ix squared. Okay, this is a dependent source too. If you draw that, okay, you will see something like that. So this is not linear. Okay, this is not linear. If you use a source like that in your system, in your circuit, that circuit will not be a linear circuit. And the second property is homogeneity. It's the property of linear systems. You have a system H. If you apply X, you get Y. Homogeneity means if you scale X with some constant value, alpha, the output will be scaled with the same constants. That's it. Okay, that's called the homogeneity property. So if your system is linear, it has two properties, linearity and homogeneity. Or you can say, if a system supports homogeneity and superposition properties, it's a linear system. Okay. Let me give a real example. Okay, consider this is a system. it's R. This is the input side, this is the output side. Is this system linear or not? I know the components, all components are linear components, so it should be a linear system. Okay. For example, let me get the system. And apply some I apply, for example, 10 volts. What's the voltage at Vout1? This is my system. Let me copy. Let's analyze that system. The voltage at this point is what? If you say this point is ground, 0, 10 volts. Okay, 10 volts. So there is no current here. Okay, if you say Ix, it should be 0 because there is no component connected. It's open circuit. So 10 volts will be divided into two same value resistors, RR. So Vout is the voltage of one resistor, 10 is the voltage of two resistors, so Vout1 is equal to half of the voltage, because two resistors have 10 volts. The midpoint should be the half of the voltage, which is equal to 5 volts. And then let's use the same system and apply a different voltage 2 times higher. Okay, so now I will get another output. If this is 0, this is 20. What's the voltage of this point? 20. What's the voltage of this point? It's 20. It's connected with a cable. So voltage of two resistors here, okay, voltage of these two resistors is 20. This is 20. This point is 0. So total voltage on two resistors, two same identical resistors, is 20. And Vout2 is the half of these two resistors. Okay, they have same value. For example, 10 ohm, 10 ohm, RR. So the Vout is the voltage of this resistor, and it is total voltage times this resistor divided by summation of two resistors, which is 2R. So result is 10 volts. So I know that this system is linear because it only contains linear components. When I apply 10 volts, output is 5 volts. So when I apply 20 volts, what should be the output? I can make this estimation using the linearity property, homogeneity. Homogeneity says if you apply some inputs, okay, my input is 10. I get some outputs, 5 volts. If your system is linear, without analyzing that circuit, you can say if you do alpha times x, okay, so alpha is 2, the output should be 2y. Okay, it should be 10 volts. Is it? Yes. Okay. Question: if you apply 30 volts, if you apply 30 volts as an input, what should be the output? Without analyzing that system, please answer the question. If I apply 10, I get 5. If I apply 20, I get 10. If I apply 30, the system is linear, so output should be y, because 30 volts is 3x, output should be 3y. Okay? Good. Or for example, this comes from homogeneity, and using this superposition you can say if I apply two different inputs, for example, I apply 2x, I apply 3x, I know the outputs. So if I apply this summation of these two inputs, okay, the output should be summation of these two responses. The response of 2x is 2y, response of 3x is 3y. So if I apply 50 volts, summation of these two inputs, the output will be the summation. The summation of these two outputs is 25 volts. Okay.